Okay, it's February 18th, 2017, and this is another StarRider CPU board. And here's what happens on this one when I turn it on. It runs the rug test, but then it immediately fails with a 625 error code. And it looked like it barely said 7 there. Here, I'm going to reset. Run it through again. 625. Okay, so the rug test is a test of video RAM, and the video RAM is on a different board than the CPU board, so I don't think the video RAM is actually bad. So I'm going to look in the documentation and also, if necessary, the program disassembly and see what 625, code 625 is supposed to mean. So according to the StarRider manual, an error that starts with 6 means it's bad RAM on the CPU board. And that RAM is, I believe, all of these right here. So maybe I can either try to figure out, I'm sure the error code 625 is telling me which RAM the problem's on, but I don't really know if how well I can parse that or make use of that, so I might have to write a little test program that tests each of the RAMs and then tells me where the problem is. Before I write this test program, I have to notice that the legs on this guy they seem like they have some acid damage, so I wouldn't be surprised if it's this guy. In fact, if we look, it does say U25, so maybe 625 refers to this. Okay, I found in the ROM program where this test fails, and it looks like I was right. So here's where it loads the 6 for the 625, and then depending on where in memory the RAM test failed, it'll either load like a 5, it'll load a 5-1, a 4-4, a 3-6, or a 2-5, or even a 14. And if we look on here, that corresponds with 5-1, 4-4, 3-6, 2-5, and 14. So that's really cool that Williams actually tells you which RAM is bad. So it looks like, indeed, this one that has all this corrosion on it seems to be bad. And I don't know if it's bad or if just the legs aren't making good contact because of the corrosion. So I think I'm going to remove it, clean it up, install a socket on it, and see if I can get it to work just by replacing it. Okay, it is now November 15th, 2017. About 9 months. 9 months have passed since I worked on this board, and last time I was working on this board I was living in an apartment while my house was being built. Now my house is finished, I've moved into my house, I'm in my new office. And I'm finally getting around to picking up where I left off before. So in my last video I said that I was going to replace the RAM, which I did, and then what happened is I decided I was going to clean the board while I was at it, wash it. So I washed it with vinegar and water, scrubbed it down, got it all nice and clean, and then I foolishly forgot that I needed to let it dry. So I plugged it in while it was still wet, and bad things happened. And at that point, I was discouraged and frustrated, and I was in the middle of getting ready to move anyway. So I was forced to pack everything up and, put it on the shelf. But now I'm settled in, ready to dive into this again. So here's what happens. So, well, first of all, let me say that I think probably most of the board's good. I think probably hopefully just 1 or 2 components got fried when I had the had it wet when I turned it on. So here's what happens now when you turn it on. Powering on, it immediately just starts playing the disc, and I don't know if you can see, there's like black lines going down the disc video. And I happened to try plugging this in without any power before, so the board was unpowered, and it kind of did the same thing. So I got out my logic analyzer and probed around on the CPU, and what I saw was that all the address lines are pretty much dead. There's no activity on the address lines, and all of the data lines are held high. And also, I happened to notice that when I was touching it, it was getting really hot right around here. And I know the clock is good because the clock actually comes from this board, the VGG board. There's no clock on this board. The clock comes through this connector. So I know the CPU is getting a clock. So I think probably the CPU is destroyed. And I'm hoping if I just replace the CPU that everything will spring to life. I got a brand new CPU installed. Now I'm going to turn it on. Let's see what happens. Looks like pretty much the same thing as was happening before. So how could that be? Let's see the address lines. The address lines are still dead. Okay, well this is interesting. So now I'm thinking maybe the CPU was okay and there's something else going on. So now I'm going to probe each individual pin and see if, you know, maybe the interrupts are being pegged, you know. The interrupts might be held low, which would kind of disable the CPU, I would expect. So I'm going to probe around and see what I find. So I decided to hook up my logic analyzer to the CPU because I wanted to see where the program execution was going. And here's what's supposed to happen. I disassembled this ROM. When the CPU resets, it reads FFFE for the memory location to jump to. It reads FFFE and FFFF, and that is supposed to jump to E00E if everything's working correctly. But here's what actually is happening. Where are we? Now, I only have 16 lines on my logic analyzer, so the top line I used for the clock, so the top bit is always going to be 0. So instead of FFFE, it's going to say 7FFE. So it starts at 7FFE, then reads FFFF to get the location to jump to, and then it's supposed to jump to E003, which is actually going to show up as 6003 here, but it's jumping to 7013, which is either going to be F013 or 7013. I don't know because I don't have the top bit, but it looks like maybe the CPU is reading the ROM incorrectly, because most of these bits are correct, but obviously this one is not correct, and there's an extra bit here set here that's not correct. So I think what I'm going to do is replace the top ROM and see if that improves things. Okay, I got a new ROM here. Let's see what happens. But the same thing happens. Okay, looks like the same thing's happening. So I was going to say, if the same thing happens, the next thing to check for me is the path that is between the ROM and the CPU. Because maybe something something between the ROM and the CPU is bad. Okay, here's the schematic. Here's the ROM U52 that gets booted when the game turns on. And here's its data lines. Its data lines are connected to this bus, which are, these lines come into this 74LS245, which basically is a bidirectional buffer. Depending on whether this direction pin is high or low, it'll pass data from one side to the other. And then after that, it goes straight to the CPU. So the only thing between the CPU and the ROM is this 245. So that could be what's causing the problem. Unfortunately, since there's a lot of other devices on this data bus, any one of these devices could be causing the problem. So I'm going to try this one first. Another thing that's kind of interesting is here's a heat map of the CPU board while it's turned on. And here are the 6821s. Here's the CPU, which apparently getting that hot is normal. Here's the logic for the reset and the watchdog. And here, which is also kind of hot, are the 245s, which I'm going to be looking at. So maybe the fact that they're extra hot means one of them is shorted internally, or it could just be that's how they just run normally, because I haven't actually looked at the heat map of a properly functioning board. So this is just conjecture, but I'm going to look at those 245s, or at least I'm going to look at this 245 and see if one of the lines is always stuck. And hopefully it is, because otherwise I'll have to unplug every single one of these ROMs or RAMs until the problem goes away, which could take a really long time. And I probably should have pointed this out before, but the problem is right here. Data line number D4, which is the 5th data line, is always stuck high, so that appears to be what the problem is. So some device on the data bus is holding that line high. The question is, which device is it? Okay, I think I found a problem. I just noticed this. There is a trace that has been lifted up as a result of me removing the old memory and installing the socket. So that is definitely going to be a problem. It's going to mean that this RAM cannot be read properly, and probably the one next to it. And so I don't know if that's the problem or that's something I definitely am going to need to fix. So I used my multimeter to figure out what this trace is connected to, and it was actually connected to these legs on these RAMs. And then I traced it over to one of these legs around here, and then looked on the schematic, and it was actually B4 pin 14. So B4 might be the bit that is always stuck high. Actually, yeah. 1, 2, 3, 4, 5. So channel 4, the 5th one. Yeah, so that's the one that's stuck high. So I think this is related to the problem I'm seeing, but what I don't understand is why, if this is not connected at all, why it's coming out high on this end. Maybe that's just the way the 245 works. If it's floating, it automatically makes it high. I don't know. But it appears like this is, well, except the RAM's connected though. So, I don't know. Maybe the routing on the PCB goes from here, and then at this point, it goes up to the RAMs. So maybe all the RAMs, the 5th data line is disconnected because this trace is broken. Maybe they all go through here. Yeah, maybe that's what it is. Anyway, it seems like it's related, so I'm gonna... I hate to take this socket off again because this board's so fragile. Maybe what I'll do is add a jumper wire on the, I could either I could probably turn the board over and add a jumper wire between these 2 points, which is what this trace was doing, and then hopefully that'll mean the rest of the, the ROMs and the RAMs will all start working, but I'll do something and report back. Okay, so yeah, I just did a test. This pin right here is connected to these pins on all these ROMs. So the fact that this trace is broken means the fifth data line on all these ROMs can't get to the CPU. So I think this is the problem. I think if I just add a jumper wire, it should fix everything. So maybe the fact that I turned the board on after washing it had absolutely nothing to do with the problem, and I didn't fry anything. And actually, that would kind of make sense because I think it was pretty dry. It's so weird how I think something's wrong and I fixate it and I'm like, oh, this is definitely the problem. And then it turns out to be totally not the problem at all, just something else. Okay, I have applied that jumper fix I was talking about. I did take the RAM out, but let's see if the thing will at least boot and go into self-test. Not liking the looks of this. Seems like it's still doing the same thing. Okay, even though the behavior appears the same, we are making progress because now the data line on the ROMs is moving, where before I don't think it was moving at all. So progress is being made. Well, that's not going to do anybody any good. Okay, fix the ROM being seated wrong. Now we're going to get anything different. Oh man, looks like it's still the same. Okay, so I traced the program flow using logic analyzer techniques and I found something odd. So at, let's see, F82D it does a clear instruction, then in F830 does another clear, then F833 does another clear. So if we look over here, this is the F82D, then it goes to F82E, and then all of a sudden, for some reason, it goes back to F820, F82, and F822. So even though I just barely programmed a new ROM, I'm gonna try yet another ROM, because this looks like the ROM program itself is corrupted somehow. Okay. Well, that's interesting. The pattern is a little bit different, but it still looks like it's... Yeah, the pattern's a little bit different. You can see like a distinct dark pattern here on the video RAM. Still not working though. Okay, this is turning into a really hard problem to solve, but I have a feeling that once I do find the solution, it'll seem obvious. Okay, so by hooking up the logic analyzer, this is part of the program that gets executed right after the game boots. And it's just doing some setup stuff here, setting up some hardware. And right around here, when it loads this FDCD value into the X register, then it goes through a short little loop, and it loads from that ROM location and writes to this C000 location. So what it's doing here is it's actually taking values from the ROM and storing it into the color palette memory, because it's going to do a color test. When you first turn StarWriter on, it does this, it slowly fills the screen with different colors, so it needs to set up a color palette to do that first. So here's the part where it sets up the color palette. So as I've watched the program flow in my logic analyzer, the program kind of gets lost somewhere around here. It loads the value from the ROM, stores it to the color RAM, checks the index, the memory pointer to see if we're done. If we're not done, it loops again. So I've seen some really weird behavior. At this part where it's loading these values, it's supposed to load in values of 0, 0, F0, F0, FF. I was seeing it, now maybe I'm reading the logic analyzer wrong, but it looked like it was loading some garbage. And so the thing that I changed on this board was I removed a bad RAM chip, installed a socket, and while I was doing that, I accidentally broke a trace. So I'm wondering if I think the problem has got to be near that socket that I installed somewhere, because that's the only thing I've changed, unless I did accidentally fry another part of the board. But it seems reasonable that the problem's going to be near that socket. So I've got that to keep in mind. I also know that when it tries to read this ROM location, it seems like it gets garbage, or perhaps when it tries to store to the color palette. So there might be another component that's connected to the data bus that's interfering when that happens. It's really hard to say. I kind of wish my logic analyzer was a little bit more sophisticated. So the next thing I can think of that I can try is just writing a really small ROM program that doesn't do anything except loads from this memory location and just goes in a loop. And I'll see if doing that causes my little program to behave strangely. If that works, then I'll try just storing to the color palette memory in a loop and seeing if that works correctly. I'm hoping that if I do small little programs that exercise that functionality, that something's going to go wrong, and then I can take a logic probe and start poking around in the board while my little program's running, and hopefully I'll see a device that's not supposed to be accessing the data bus, and then that'll show me hopefully what's going on. But this is really challenging. Okay, I think I finally figured it out after a lot of trial and error. So what I've got here is I've removed all the ROM chips. I have just one ROM chip in here to minimize variables. I took out the new RAM chip I added just in case. And here's what I've done. Okay. So I wrote a little assembly language program to become the new ROM based on what the game was doing anyway upon boot up. So I knew that the problem was near the new socket that I added, or I suspected it was, but I couldn't figure out exactly where. I knew that the main ROM program would start to fail pretty soon into its execution, so it didn't get very far before it failed. And as I captured the address bus of the CPU with my logic analyzer, I noticed that even when I wrote a simple program like this that was pretty short, I noticed that the same memory locations that were being accessed at the beginning of the program, for example, you can see right here at the very beginning of the program, I clear and set the LED on the board, which is at memory location C880. I noticed that the program would continue to write to this location well after, it would write to the location over and over again, and the program counter of the CPU would be wrong. And so what I thought was happening was, I thought when the CPU queried the ROM for its next instruction, that something that was on the data bus was giving corrupt instructions back to the CPU and causing the CPU to do branches back previously in the code. So the CPU is basically stuck in an endless loop. This is my theory. My theory was this, that the CPU was stuck in an endless loop because the data instructions it was getting were corrupt, and so it was getting these random branch instructions and going backward. So I was trying to find a device on the data bus that was corrupting the instructions. So in order to find this, I kept simplifying, I kept commenting out my program like this one. I kept commenting stuff out, hoping that eventually I would comment out enough that the problem would go away. And the problem actually did go away the more I simplified the program. But through trial and error, I tried every single memory location that is accessed by the simple program, and none of them seemed to cause the problem if I isolated them. So then I was kind of feeling stumped and discouraged. I'm like, I don't know what is corrupting this thing. But then I realized, I had kind of an aha moment, and I realized that the smaller I make the program, if I make the program small enough, then it starts to work. And so I thought, maybe it's not the data bus that's corrupted, maybe it's the address bus that's corrupted. Maybe the reason these same instructions keep getting executed over and over again is because one of the address bits is corrupted, and so when the CPU goes to retrieve instructions from the ROM, it's actually retrieving the same instructions over and over again and executing them over and over again because one of its address bits is corrupted. And so then I went back and I looked at my socket job again. Actually, I got a multimeter out and I said, I'm going to test every single one of these pins to make sure they're all connected like they're supposed to be. And I found another one that was disconnected, and it's actually this one. And I don't know if you can, well, this is in the shadow, but there is actually a trace right here where I'm pointing that it appears to also be broken. So yeah, this line is disconnected, and if this line is disconnected, then a line up here on this ROM is going to be disconnected because these traces are all used by these ROMs. And so this is actually making a lot more sense. There's another broken trace on the board that I didn't notice before. Apparently this section that was acid damaged is pretty fragile, and these traces are falling apart. And so that's probably what this problem is. Now, I'm not saying if I fix that everything's going to start working again. I've learned not to make those kind of outrageous claims, especially on StarWriter, but I think that's definitely causing my current problem, and it's probably going to get me a lot farther once I fix that. Okay, I've made that repair, cleaned the board a little bit more, put the original ROM back in, just the top one. That should be enough to run the color test. So let's see what happens. Oh, thank goodness. Looks like it's working. Man, that took forever to figure that one out. Okay, well, I'm going to put the rest of the ROMs back in, put the memory in, and then run the self-test and see what happens. Hopefully they all pass. Okay, put all the ROMs back in. I put the new replacement RAM chip back in. Let's see what happens with the memory test. Looks like the memory test passed. Okay, so the new RAM that I put in works, or it passed the test at least. And all the ROM tests pass. Yes! Phew! Okay, this... I think this board is in pretty good shape. I'm gonna hook up some controls and run through all the rest of the diagnostics, but I think most of the problems that could have happened would have already happened by now, so think this thing is finally fixed. Okay, so it seems like everything's working on this CPU board. I plugged in my inputs and all the diagnostics seem to work. So to recap, I originally found that there was a bad RAM. I replaced the RAM, but I was not diligent in checking to make sure that the traces around the RAM were not broken, because that's never really happened to me before, so I wasn't really expecting it. But this board is pretty old, and there was a lot of acid damage from these batteries that had like run down here, and so this area all had a little bit of corrosion. So I should have realized, or for the future I should realize, that when there's acid damage, traces can be broken. And so I mean, I kind of liked how I was suspicious of the ROMs and how I tried swapping out ROMs, because I have had problems with ROMs in the past. I like how I wrote a custom ROM and swapped out the CPU and watched the address and data lines to see why the program was not working. That approach did take longer because my logic analyzer only has 16 channels, so I could only monitor part of the address bus at any time. So that kind of made it hard. Or if I wanted to monitor the data bus instead of the address bus, then I had to kind of look at the instructions that were coming off the ROM to figure out which address I was at. So I have actually ordered another logic analyzer that has 32 lines instead of 16, so hopefully that'll allow me to watch what the CPU is doing a lot better in the future. But also what I could have done is just tested all the continuity around this socket that I put in. I would have found both of the problems without having to write a custom CPU program, and then I would have, if I just tested the continuity, then I would have saved myself a lot of time. So anyway, I hope you enjoyed this video. I hope you learned something, because I learned a lot, and I'll see you next time.